Okay, let's continue working with inequalities. Yesterday, we saw that that inequalities solve just like equations, except for one thing. If you multiply or divide by a negative number, you have to flip the sign. So let's go ahead and get through this and solve these. So the first problem, x divided by 4 plus 8 is less than 15. Well, we know how to do these. Cross the line, change the sign, right? I could draw the line down through here. Cross the line, change the sign. Let's subtract the 8 over. So we've got x divided by 4 is less than 7. One more step, multiply the 4 to the other side. We're just going to have x is less than 28. So just like solving an equation here, right? Let's come down and graph it. Let's just call this point right here 28. It's going to be an open circle. And let's take the line out so we can see. That arrow is definitely pointing to the left. So on here, it's going to point to the left also. And that's what we've got. Just x is less than 28. And remember, that open circle means it's not a part of the solution. 28 is not a part of the solution. It will not make that be true. Okay, so let's look at the next one. Well, I see there's variables on both sides, so let's just take letters left, numbers right, cross the line, change the sign. Let's subtract the 5x over. And let's go ahead and add the 4 over. Change that to a positive. So negative 3 minus 5, that's going to be negative 8x. And 12 plus 4 is going to be 16. Ooh, and I made a mistake when I wrote the equals there. I don't want that to be equals. The sign's got to stay the same. Greater than or equal to. Okay, next step. We need to divide both sides by negative 8. Ooh, I'm running out of space. I'm going to jump down here below this line. The negative 8s will cancel, and I've got x. Over here, 16 divided by negative 8 is negative 2. And we divided by a negative 8, so we have to flip the sign. Remember, if you multiply or divide by a negative number, you have to flip the sign. So instead of greater than or equal to, this becomes less than or equal to negative 2. So I'll just call this point right here negative 2. Extra mark, make it dark, so I got to fill that in. And the arrow is pointing to the left right there. Okay? X is less than or equal to negative 2. Let's do another one. Okay, so we got fractions here. No problem. Let's just destroy those fractions. Let's clear them out. Let's multiply by the least common multiple of 4 and 3. That's going to be 12, right? We're looking for a number that we can divide by all of the denominators. That's going to be 12. So remember, divide by the bottom, multiply by the top. 12 divided by 4 is 3 times x is just going to be 3x. 12 divided by 3 is 4 times 8 is going to be 4 times 8 is going to be 32. And then 12 times 15, that's going to be 180. Okay, let's subtract the 32 over, and I'm going to drop down here. 3x, 180 minus 32 is going to be 148. And then last step, just divide the 3. We'll get x is less than 148 divided by 3. Let's see, that's going to be 49 and a third. 49 and a third. So that one did not come out very well, but no sweat. I'm going to erase this so that we can get this up here. Let's just call this point right here exactly 49 and 1/3. Can I do that? Yep, I sure can, because there's no numbers on there. So I'll just call that one 49 and a third. Open circle, and that arrow is definitely pointing to the left, so it's coming there. All right, let's look at the next one. Can I erase that? Distributive property. Negative 3 times x is negative 3x. And then negative 3 times negative 4 is going to be a positive 12. And on this side, we'll have a negative 3x plus 27. Okay, so we've got letters on both sides, variables on both sides. Let's just take letters left, numbers right. Cross the line, change the sign. So let's add this 3x over here, so plus 3x. Maybe subtract the 12, minus 12. And what do we have? Well, negative 3x plus 3x is just 0. Like it's eliminate, it's just gone. That 12 we'd already moved over there. So on the left side, we've just got 0 is greater than or equal to 27 minus 12 is 15. Okay, now, if this were an equation, we would immediately say there's no solutions because 0 is never equal to 15. Okay, but since it's an inequality, we're actually going to have to check this, all right? We're going to have to check it because sometimes it could actually be true. Let's see if it is in this situation. Is 0 greater than or equal to 15? Does that make sense? Is 0 greater than 15? No. 0 is never greater than 15, ever. So this one is going to be no solutions. Okay, this one's definitely no solution. Now I've got a question. What if our original equation, so I am changing the sign here, but I'm pretending let's go back and pretend like this original equation was less than or equal to, and that this down here was less than or equal to 15. Now what would happen? Well, when is 0 less than or equal to 15? Again, if this is an equation, it's no solutions. That's easy. But this is an inequality. When is 0 less than 15? Always. 0 is always less than 15. So if we had this is actually all real numbers. It doesn't matter if this was, going back to this original inequality, if that had been less than or equal to the whole time, then that would mean it doesn't matter what you put in for x, it's always going to be true. So let's think about how we would graph that. Well, there's really no x there to show where we should start with a circle, but I know that it's all real numbers because 0 is always less than 15. So here's what we would do. We would just make an arrow going both ways on this entire number line, saying that everything is a part of this solution. Okay, let's see if we have any more. Nope, that's it. So I know this one's a little tricky, but it's not too bad. Rules stay the same pretty much. Just if you multiply or divide by a negative number, you have to flip the sign. All right, I know you got it. Good luck.